Hello students, today we are going to study about integrals of the form 1 upon quadratic and 1 upon under root quadratic. Both these kind of integrals can be evaluated by completing the square of the quadratic present in the denominator and then applying a set of formulae. So let us see how to start with it. For integrating 1 upon quadratic and 1 upon under root quadratic type of equations, we will be using a set of formulae. And these formula will be one of the forms that we will obtain by completing the squares of the quadratic equation. Like means if we can get a form of the type dx upon x square minus a square, then the formula will be 1 upon 2a log mod x minus a upon x plus a plus c. Okay, and if integral is of the form dx upon a square minus x square, the formula will be 1 upon 2a log mod a plus x upon a minus x plus c. And if integral is of form dx upon x square plus a square, then the formula is 1 upon a tan inverse x upon a plus c. Integral of the form dx upon root x square minus a square will give the result as log mod x plus root x square minus a square plus c. Number 5 is dx upon root a square minus x square is equal to sine inverse x upon a plus c. And number 6 is dx upon under root x square plus a square, which is same as log mod x plus root x square plus a square plus c. Okay, so when we will be integrating the integrals of the form 1 upon quadratic, that is 1 upon ax square plus bx plus c, or integral dx upon under root ax square plus bx plus c, that is 1 upon under root quadratic, firstly we need to make the perfect square of this quadratic equation there, right? And this is, we are familiar with how to do this. We will firstly make x square free from the coefficient, okay, any other coefficient except 1. So a is taken common here, and then we obtain the equation as x square plus b upon a x plus c upon a, which is equal to a times. Now to make the perfect square, the method we know, that is we will take half of coefficient of this x. So what is half of this coefficient of x? That is your b upon 2a. So we will add and subtract b upon 2a whole square, right? And we have already done it in while deriving the quadratic formula. So it will become your x plus b by 2a whole square, and the minus b upon 2a will be added to this constant term to get a result. Okay, now this form means this quadratic or root quadratic will be reduced in any one of these 6 formula, and then we can integrate that type of integral. So let us take examples to understand it. Take our next question, and the next question we are going to take is your question number 11. Your question number 11 is integral 1 upon 9x square plus 6x plus 5 dx. Okay, now you can clearly see that it is of the form 1 upon quadratic. So firstly we need to change this quadratic to perfect square form. So 6x square by method of completing squares plus 6x plus 5. So first thing is take this 9 common outside. Why? Because we need to make this x square free from any coefficient except 1. So it becomes x square plus 6x by 9 plus 5 by 9. Okay, so which is your 2 by 3. So 9 times x square plus 2 by 3x plus 5 by 9. Okay, so now the next thing I need to do is I have to add and subtract half of coefficient of x whole square to this. Okay, so what is the coefficient of x here? It is 2 by 3. And what is half of 2 by 3? That is 1 by 3. So I need to add and subtract this 1 by 3 whole square. So it becomes the added one will go along with this x square and the x term. Okay, x square plus 2 by 3 x term, and this Subtracted one will go with this constant term. So it is x square plus 2 by 3x plus your 1 by 3 whole square and plus 5 by 9 minus 1 by 3 whole square means 1 by 9. Okay, as I need to solve it, so I'll just write it as 5 by 9 minus 1 by 9. Okay, now if you observe it clearly, it is your x plus 1 by 3 whole square, right? And it is your 4 by 9, that is 2 by 3 whole square. It is 4 by 9, that is your 2 by 3. It becomes your, after taking LCM, it is 4 by 9, which is your 2 by 3 whole square. Right. So let us come back to our integral, and I get it as, because all this thing is to be taken in the denominator. So it becomes 1 upon 9 times x plus 1 by 3 whole square plus 2 by 3 whole square dx. Okay. Now take this 1 by 9 outside, and now I need to observe which form it is. Okay, so it is of the form, if I observe it carefully, it is of the form, integral of the form your x square 1 upon x square plus a square. Okay, it is your 1 upon x square plus a square. So we clearly know that what was the formula? Integral 1 upon x square plus a square was 1 upon a tan inverse x upon a plus c. So who is in place of your x? Who is in place of x? It is your x plus 1 by 3. And who is in place of a? It is 2 by 3. So let us shift it to the formula. 1 by 9 is already there. So it is 1 upon a, that is 1 upon 2 by 3 tan inverse x upon a plus c. So it makes, let's do some cancellation. So it becomes your 1 by 6 tan inverse, take LCM in the numerator and denominator as well. So it is 3x plus 1. So by 3 will be there and 2 by 3, okay, plus c. So this 3 gets cancelled and I get the answer as 1 by 6 tan inverse 3x plus 1 by 2 plus c. So it is very simple. Now next question I am going to of the form 1 upon under root quadratic. So let's take question number 12. Okay. So it is your 1 upon integral 7 minus 6x minus x square dx. Okay. Now be careful, as I have to write this quadratic equation in standard form. So the standard form of this quadratic equation is arranging it with the highest degree term first. So it is x square plus 6x minus 7 and the minus sign is taken common. But be careful that I cannot take this negative sign common outside. Why? Because it is inside the square root and we very well know that square root minus 1 is your iota and it reduces to a complex number. So it is not possible for me to take it out. So what will I do? I'll just make the perfect square of this quadratic equation which is inside the square root, and definitely I'll get any of the 6 forms here. Then I will just adjust this negative sign in flipping the term, by flipping the terms. Okay, so let us see how to do it. So let us change it to perfect square, as x square is free of anything. So x square plus 6x, half of 6 is your, half of 6 is 3. So 3 square is 9. So I will add and subtract 9. Addition will be with this x square and 6x term and subtraction here. So it becomes your x square. It is your x plus 3 whole square and it is minus 7 minus 9 is minus 16. I can write it as minus 4 square. Okay. So this integral reduces to square root of minus, okay, and it is your x plus 3 whole square minus 4 square. Okay, let's close the bracket here. Now I will adjust this negative sign. How can I adjust it? Because I can't bring it outside the square root. So what will I do? I will just interchange the position of these terms and this negative sign will be adjusted. How? 4 square will be written first and then minus x plus 3 whole square. Okay. So see, this negative sign is adjusted. Okay. So if I open this bracket, this 4 square will be positive and x plus 3 whole square will be negative. So it is adjusted like this, right? Now I have to view that which formula it is there. Okay. So which formula it is making, right? So you can very clearly view that it is of the form 1 upon root a. This is a and this is x. A square minus x square dx. And the formula is sine inverse x upon a plus c. Okay. So it is your sine inverse. X is your x plus 3. Okay. And upon a upon 4 plus c. Okay. You need to be little careful if something is like 3 minus x whole square here. Okay. Then you have to take this dx will change to minus dt as we did in our question number 3 of this same exercise we took in the very first line. Okay. So otherwise it is okay as it is x plus 3 whole square. So derivative of it, if I need to divide, then it will be your 1 itself. Okay. So sine inverse x plus 3 by 4 plus c is the required answer. Let us take one more question of 1 upon under root quadratic type, and your question number 14 is 1 upon integral 8 plus 3x minus x square dx. Clearly it is of the form 1 upon root quadratic. Okay, and this quadratic equation is not in standard form, so I need to express it in standard form, keeping in view that the negative sign should not be taken outside. Okay, we need to do the adjustments of this negative sign after this is made perfect square. Okay, so this x square minus 3x minus 8, again x square is having coefficient 1, so I'll just simply half of coefficient of x here is 3 by 2, so I'll add 3 by 2 whole square and subtract 3 by 2 whole square. So it becomes your, it is your, as negative sign is there, so it is your x minus 3 by 2 whole square, and it is your, this will become minus 8 minus 9 by 4. Okay, so be careful while calculation. It is minus 32 minus 9 by 4. Okay, so it becomes your x minus 3 by 2 whole square minus, it is 41 by 4. Okay, as both signs are negative, so it is your root 41 by 2 whole square, as I need to express it in the form of your a square minus b square. Okay, as per this question, so a square minus b square, right? Now I will just write this equation in this form. It is 1 upon root minus is x minus 3 by 2 whole square minus root 41 by 2 whole square. Now to adjust this negative sign, what I need to do is I'll flip the positions. So it becomes your root 41 by 2 whole square at first, and then x minus 3 by 2 whole square. The negative sign is adjusted. Now again I can view which form is this. Again I need to use the formula of integral 1 upon root a square minus x square, like, which is again your sine inverse x upon a plus c. Now see, it is your sine inverse. Who is in place of x? It is x minus 3 by 2 x upon a plus c. Okay, so let us take LCM. It is 2x minus 3 by 2, that will be cancelled with this 2 in the denominator. Okay, and it is root 41 plus c, which is the required answer. Right? So I hope the concept of your solution of the form of integrals 1 upon quadratic and 1 upon under root quadratic is clear to you. Thank you so much.